Okay, today we're going to talk about inverse functions and identity functions. So, first question, the number of cells of a culture n in t hours after t hours has been established by this graph. Okay, so the relation represented is a function. Give reasons why this is a function. Okay, so this is a function because for every value of um, t, there is one n value. So for every value, for a time of 8, there's an n value. For a time of 14, there is an n value. I could also do a vertical line test, and if I did a vertical line test, it would only go through the graph once. So for every x value, there's only one y value. Okay, let's look at question 2. State the independent variable and the dependent variable. So the independent variable is time. Okay, that is our independent variable. And our dependent variable is the cell culture. Okay, so our dependent variable is the cell culture n. Okay, that is our dependent variable. Okay. Okay. Okay, next. Question C says, estimate the initial number of cells in this culture. So the initial number of cells the initial number of cells is when we start at time 0. So the initial number of cells when time is 0, it looks like it's about 4 cells. Okay? If you're close, that's fine. Estimate the value of n when t equals 4. Okay, so when t equals 4, I'm going to go... Yikes, this marker's not very good. Okay. When t equals 4, I'm going to go from here all the way up to there and then over. And it looks like it goes to an n value of 8. So when t equals 4, I'm going to go from 4 all the way up and over, and it looks like 8. Okay, estimate the value of t when n equals 32. So what I'm going to do is I'm going to go start at 32. I'm going to go 32. I'm going to go over and down, and it looks like it's 12. Okay, so I start at 32, I go over and down, and then I get 12. Question F. Estimate the interval of time over which the number of cells varies between 64 and 128. So if I go to 64 over and down, I'm at 16 hours. If I go to 128 over and down, I'm at 20 hours. So the interval of time is between 16 and 20. Okay. So let's look at number 7. You may have something like this on the quiz coming up, where I'm going to give you an equation. So in this example here, I've given you an equation. The cost of renting a car is given by this formula here. CK equals 150 plus 5K. So find the cost of renting the car for 30 kilometers. So that means I'm going to drive the car 30 kilometers. I'm going to plug in 30 in for K, and then the cost is going to be $300. Let's talk, before we continue, what do each of these things represent? 150 represents the initial cost. Okay. 150 is the initial cost. Okay. And 5 represents, I need a better pen. All of these pens are no good. I need to throw them away. Here's a good pen. Okay, so 5 represents the cost per mile. Is it miles? Or cost per kilometer? 150 represents the initial cost of renting the car. Okay. So, anyways, find the cost when I've gone 72 miles. So 150 plus 5 times 72 gives me this. Okay, a group of friends pay this much to go to the Ray's Village. Determine the distance they traveled since they've paid this amount. So that's the amount. We need to figure out how far we've gone. So we subtract 150 on both sides, and we solve for K. All right, let's move on. Okay, so before we just start solving questions, I want to talk this through. So today we're going to talk about inverse functions. Okay, and one thing I want you to watch today is to go onto YouTube and go to Professor Dave. You can simply go to YouTube and type in Professor Dave Explains Inverse Functions. I guess I saw people taking pictures of this and then it got to that link. Okay, I guess that works too. So if I have an inverse function, excuse me, I can plug in a value and get some value here. If I plug it into the inverse function, I'm going to end up with what I started with. If I started with 1, then my inverse function is I'm going to end with 1. Okay. So if you have a function that is many to 1, then it won't have an inverse function. So we'll talk about that in just a sentence. So we've talked about the vertical line test for functions. Okay, but if you want to have a oh my gosh, this highlighter is horrible. Okay, if you want to have, if the inverse is a function, it needs to pass a horizontal line test. So if, oh my gosh, if the inverse is a function, it must pass Okay, let's talk a little bit more about what that means. So, when we're solving for an inverse function, we're going to be switching the x with the y and the y with the x. And so, while functions satisfy the vertical line test, if they don't satisfy the horizontal line test, then it's not going to have an inverse function. So, so many to 1 does not have an inverse function. Okay, and we'll see some examples of that in just a minute. Okay, now the important thing is when we start talking about inverse functions, we're going to use this symbol right here with, it looks like it's a little negative power. Now that does not mean 1 divided by the function. Okay, it's important that you know this is not the reciprocal. This does not mean this. This does not mean this. Okay, so and we're going to talk about this pretty soon. Okay, so this is cut and pasted from Professor Dave, but if you plug something into the function and if you plug it into the inverse function, you're going to end up with what you started with. That's what this is saying here. If you've got a function that's an inverse of itself, then it's going to be a reflection on the line y equals x. Okay, and this is something we're going to be seeing today. It's going to be a reflection on the line y equals x. Okay, and you could see it kind of looks like, if you flip it over, it's a reflection. Now, if I've got the graph y equals some parabola, if I reflect it on the line y equals x, then the reflection is going to look like this. And as you can see, this blue graph is not a function. So in order to make this a function, we can, if we were able to restrict it, if we could restrict the domain, and if we said, okay, we're only going to use half of the initial function, so I'm going to use only half of that parabola, then that means that I'm only reflecting this part here, and if that's the case, then it will be a function, because I could do a vertical line test on this blue graph and it'll be a function. Okay. All right, this is all theory that we've been talking about. Let's solve some numbers here. Let's do some stuff with numbers. Okay. So all of this bold writing is from Professor Dave, but these are the steps. You're going to instead of writing f of x, I'm going to write y. So here we have this is equal to 2x plus 3. So I'm going to rewrite it as y equals 2x plus 3. Then we're going to switch out y and turn it into x. So I'm going to replace this y, and now I'm going to write x, and where I have x, I'm going to replace it and write y. Okay, and now the final thing is we're going to solve for the new y. So to solve for the new y, I subtract 3 on both sides, and then I get x minus 3 equals 2y, and then the final step to solve for y is if I divide by 2, and then I end up with x minus 3 divided by 2 equals y. So what I've just done is step 1, I changed f of x into y. That's what we wrote y. Step 2, we're going to switch the y with the x and the x with the y. So this y became x, this x became y. And then the final thing was we solved for y. So we subtracted 3 on both sides. I got x minus 3 equals 2y. Divided both sides by 2, and we got this. Okay. If I graph this, it's going to look like this. And if I graph my original function, it looks like this. Okay. So okay. Check to see if the composite of the function and its inverse is going to equal to this. So my inverse function is x minus 3 over 2, right? And then f of x is 2 times that stuff plus 3, right? So 2 times this stuff plus 3, right? F of x. So my inverse function we just showed was equal to this, x minus 3, right? Over 2. So my original function is 2 times whatever that stuff is plus 3. So I have 2 times whatever that stuff is plus 3. Okay, so now if I'm simplifying this, I'm going to divide both sides. The 2's can cancel out, and then I have x minus 3 plus 3, and then I get x. So they may ask you to check or to show, and if they ask you to show something on the test, you have to show the work. You can't just say the answer is x. Okay, so now we're going to show it the other way too. F of x is 2x plus 3, so I'm going to put that in here, 2x plus 3. And then I'm going to plug in this red stuff into my inverse formula. So I'm going to put, instead of x, I'm going to write 2x plus 3 minus x over 2, right? This red writing minus 3 over 2. Okay, well, the 3 minus 3 is going to go away, and then 2x divided by 2 gives me x. Okay. All right, so consider this function. This is f of x equals x squared. Explain why this function does not have an inverse. So it doesn't pass the horizontal line test. If I drew a horizontal line through it, it would be a sideways parabola like we saw on the previous page. So for every y value, there is 2 x values. Okay. So is there an inverse if I restrict it to x greater than 0? And the answer is yes. So here it is when it's greater than 0, and if we do like what we just said before, we're going to switch this y, turn it into an x. You're going to turn this x into a y, and then if I take the square root of both sides, I end up with y equals plus or minus square root of x. So if I restrict the domain to x is greater than 0, then I'm going to say my inverse function is equal to the square root of x. Okay. And we need to restrict it to x is greater than 0 because we can't take the square root of a negative number. Okay, and here are the 2 sketches. You might want to hit pause if you need help for a minute. Okay. So find the inverse function. So here I have y equals 3x plus 1. I'm going to turn this y, change it into an x. I'm going to have this x, I'm going to change it into a y, and then I'm going to do the algebra. I'm going to subtract 1 on both sides, I get this line. I divide both sides by 3, I get this line, and so here is my inverse function. Okay, let's look at the one over here. Okay, so I've got y equals x plus 2 over 4. I'm going to change this y into an x. I'm going to change that x into a y. And then to solve for y, I have to multiply both sides by 4, then subtract both sides by 2, and now I've got my inverse function. Okay, this one here I graphed in blue, and the original function I graphed in red. Okay. So for each of these functions, draw the inverse function. The original function is already drawn. So I think the easiest thing to do is here I've got this coordinate here is negative 2 comma 0. So then I'm going to be plotting 0 comma negative 2. All we do is we switch the x and the y values. Okay, this point right here is 0 comma 5. So the new point over here is going to be 5 comma 0. We switch the x and the y values. My domain of this original graph, the domain is from from negative 2 to 0, right? It's from negative 2 to 0, left and right. And then the range, it goes from 0 up to 5, right? So the domain is going to be, we're switching the x with the y, and we're switching the y with the x. So the ranges and the domains switch. So for this guy here, the range is y is greater than 4, and the domain is that x is less than or equal to 0. So the domain and the range switch, and since this point right here is 0 comma 4, then this point right here is going to be 4 comma 0. Okay? And if you hold it like this, so your dotted line, it kind of looks symmetrical, doesn't it? Same thing here. If I look at the dotted line straight up and down, it looks symmetrical. Okay. Okay, this is a straight line, so the domain and the range are all real numbers for this. Okay. For the original graph, the one that's black there, the range is y is greater than 0. So that means my domain is going to be y is greater than 0 for the inverse function. Those are going to be the same. Now, for the domain of the real numbers, we know that this black graph, this one right here, is all real numbers, right? So if the domain on the original function is all real numbers, then that means the range of the inverse function is all real numbers. Okay. Oh, okay. So this is a special case. If I have a point at 0 comma 2 and another point at 2 comma 0, if you switch the 0 and the 2, this is an inverse of itself. So it's the same line. And you can see that if I reflected it on the line y equals x, you can tell that it is perpendicular to that line, and it is simply symmetrical. Okay, so explain what the horizontal line tests. So when you take an inverse, you switch the x with the y and the y with the x. If the graph of the inverse, when you graph the inverse, it won't pass through the vertical line test if it does not pass. So, okay. This has an inverse function. Using the horizontal line test, the inverse is not a function. If I do a horizontal line test, the inverse is not a function. Okay. So how could we make II and III? How could we make the inverses functions? So for this one here, we could restrict it for x is greater than or equal to 1. So if I restrict the domain of f of x to only values greater than 1, then that means I'm only going to use this half of the graph, and that would make it a function. If I restrict the domain between -2 and 1, that means I would only be using this portion of the graph from here to here. And if I'm only using that portion of the graph between -2 and 1, then that means the only y values I would be using would be this. And if those are the only y values that I'm using, then then the inverse would be a function. Okay, so if we got mapping, so the inverse, notice they kept the bubbles in the same place, but notice they changed the arrows switch direction. Okay, when you do inverse with mapping. Okay, so state which ones are going to have inverses. So this is not going to, the inverse is not a function here, because you have 1 to many, and this is a function. And take a look at this. Okay. And I don't think I have one of these on the test, but we did do intersection last semester, and I think it's worth talking about. So I've got this equation. I'm just going to talk this through here. I've got this equation, y equals -2x plus 5. Okay, so if I go to find the inverse, I change the y to an x and an x to y. So I would say x equals -2.5, y plus 5, right? So I'm trying to find the inverse. I could subtract 5 on both sides, divide both sides by -2.5, and then I end up with y equals 1 divided by -2.5 gives me this, and 5 divided by 2.5, -5 divided by -2.5 is +2. So my inverse function looks like this. So if I take this equation here, my inverse function, and if I take my original function, which is this, right, then I could find the intersection using the calculator. So using the calculator, I could say -2.5 x plus 5, and then the other one would be -0.4 x plus 2, and I can graph those. I'm going to do zoom 6 to get a normal graph here. Okay, if I want to find the intersection, you might recall we do second trace, and then I go down to intersect, I hit enter, it says first curve, it's listed this equation, I hit enter. Now it says second curve, it lists the other equation, I hit enter. It says guess, I hit enter again, and my intersection is going to be 1.4, 1.4. Okay. Alrighty. That's it.